This is AP Calculus. This is Unit 5, Fix-Up Solutions. Let's go through these one by one. For number 1, you see that what house are we in? We are in trig house because we have this trig function here, which means we need to look at this u. When we take the derivative of u, that's going to be 3x squared. That's not 1. So when the derivative of the inner is not when dinner is not 1, then we use u substitution or taxman. I think for this video I'm going to exclusively use taxman. It seems like that's what a lot of us are using. So let's do that. For taxman we need a u, we need the taxman, and we need the derivative of u. Alright, so what is our u? Our u is our x cubed. Our taxman, he's knocking at the front door, he's x squared. And what is the derivative of this? That's going to be 3x squared. So this fraction right here becomes 1/3. So when we pay the taxman, it's going to look like this. So x squared gets paid. He's now 1/3. And we still have our cosine of u. Okay, and I guess there's a dx there still. We aren't in multivariable calculus because that's kind of how taxman works. It's not very formal. When we do the anti-change, that's the same. Anti-change is same, so there's not going to be any more negative. So this is going to, we're taking the antiderivative now. We have 1/3 sine, there's sine of u. And I'm not going to write u here. I'm just going to skip that step. U is actually x cubed plus c. And that's our final answer. All right, and moving on to number 2. We have the integral of all of this, the antiderivative. So since there's a plus here and this is to the power of 1, what we can do is we can use this integral and we can distribute it into each of these terms. And that applies when this power is 1 or when there's not a power there, and when there's a plus or a minus. So let's get rid of all that to see what happens. So this is going to be the integral of sine of 2x dx, and we're going to add that to the integral of cosine of 2x dx. All right, so now for this one we're in trig house. Trig house means this is our u, and our dinner is 2, not 1, so that means we're using u substitution or taxman. We're using taxman exclusively for this video, so u is our 2x, our taxman, he is knocking at the front door, he's invisible, he's 1, and our derivative of u, that's equal to 2. So our fraction here is 1/2. And we'll pay the taxman now. So when we pay the, well, that variable looks weird. When we pay the taxman, it is now a 1/2, and it's still a sine of u dx. Actually, I think taxman, I've been doing taxman wrong for the last little bit. I think I should still leave this as a 2x dx. And that's just so we don't have to resubstitute it out. We only use the u substitution. We only substitute this when we're actually doing u substitution. So now that we've paid the taxman, we're allowed to go on. So antiderivative of sine, anti-same means change. That means we're going to have a negative in here. So negative 1/2 cosine of 2x plus c. Perfect for that side. Now let's go on this side. So it's basically the same thing. We're going to use taxman. So I don't actually want to rewrite all of this. It's the same exact thing. That means our integral down here, doing all the same work, we get integral of 1/2 cosine of 2x dx. And now when we take the anti-change means same, so don't add any more negatives. And remember our sign in between here is a plus. So it's going to be plus 1/2 sine of 2x, and that's going to be plus c. And you really only have one constant that you're adding. You can think of this as your, I'll write this in a different color. You can think of this as C0 and C1, and you can make a note on the side to be formal about your math. say note, C is equal to C0 plus C1. And that just makes it so that you can write just plus C at the very end. So what is our final answer? Our final answer is negative 1/2 cosine of 2x plus 1/2 sine of 2x, parentheses, plus C, and that C is both a C0 and C1 together. And you don't have to do that, you can just say plus C, two C's make a C, and that's our final answer. All right, let's move on to number 3. For number 3, we're going to have E house. That means our inner, our U is T over 2. Dinner, the derivative of the inner, is 1/2. It's not 1, therefore we're using U substitution or taxman. So using taxman, we need our U, we need our taxman, and we need our derivative of U. All right, so our U is T over 2, T over 2. Our taxman is at the front door, he's 1/2, and our derivative of T over 2 is 1/2. Oh, it looks very similar to the one that was on the pretest. 1/2 divided by 1/2. This is equal to 1. So we're going to pay the taxman. It's no longer a half, it's a 1. So it's going to be, I'm not even going to put it, because 1 times anything is anything. So it's going to be integral of e to the t over 2 dt. We pay the taxman. Let's go ahead and take the antiderivative of this. Antiderivative of e to the t over 2 is just e to the t over 2. And don't forget your plus c. All right. There's our final answer. Moving on to number 4. So, we have a fraction. Let's get rid of that fraction. So when we take the, actually I'm going to write it up here so we don't run out of room. When we treat this as a non-fraction, it's going to be x times all of this stuff to the -1. And notice that square root is a 1/2 power, so eventually I'm going to have a negative 1/2 power up here. And let's see how that looks. So it's going to be x times 3x squared plus 5, all of this to the -1/2. Don't forget our dx. So we rewrote it without a fraction. Very nice. All right, now we have to figure out what house are we in. We are in power house because this is raised to a power. That means this is our u, this is our inner. When we look at dinner, dinner is definitely not 1, which means we're using u substitution or taxman. We're using taxman, of course, so we need a u, we need a taxman, and we need our du. So our u is 3x squared plus 5, 3x squared plus 5. Taxman is knocking at the front door, he is x. Our derivative of this is 6x, 6x. So this fraction then becomes 1/6. All right, let's go ahead and pay the taxman. Down here, we're paying him with 1/6 and rewrite the rest of the equation. So that's going to be a 3x squared plus 5 to the power of -1/2 dx. Okay, we've paid the taxman, now we just need to take the antiderivative of this. So it's going to go up a power. So -1/2 plus 1 is just a positive 1/2. So taking the antiderivative, and this becomes 1/6, all of this thing to the, so all this thing, 3x squared plus 5 to the power of 1/2 now. And we need to divide down by a half. So when I divide by a half, I'm going to actually multiply by 2. So it's the same thing as multiplying by 2 over 1. And when I do that, this is going to simplify a little bit, but I'll still have my plus c. So my final answer is just 1/3 of 3x squared plus 5 to the power of 1/2. I could have left this whole thing as square root of 3x squared plus 5, but it's the same answer. And there is our final answer. All right, we're halfway done. We're on the second page now. We're on number 5. So I'm taking the antiderivative of this thing. And you'll notice if you use taxman, it won't work. It'll be a variable rate. Let me just show you that what you should get if you try to use taxman. I already know it won't work because I can see ahead. If I take the derivative of x, it's going to be 1. And when I divide this by 1, I'm still left with x, and I'll be in multivariable calculus. But let's see something wrong. So I'll do this in a different color. I'll do this in red. This is not what's going to work. So I'm going to say, I'm going to use taxman. Let's use u. Let's use taxman. And let's find the derivative of u. And u is going to be, I would assume it would be x plus 2, but you'll notice that that also doesn't work because you're not in a house. Like, this is to the power of 1. You could say, oh, you're in power house because it's to the power of 1. No, that's not power house. There's no house here. So let's pretend that parentheses you might have thought was a house. We'll say that's x plus 2. We'll say taxman was the x to the 1/2 power, or the square root of x. The derivative of u is just 1. And when I look at this fraction is still x to the 1/2. And remember, you can never pay taxman with a variable rate. So I've already done 2 incorrect things. I have no house. I'm paying with the variable rate, and let's assume that you still haven't noticed that you've made an error, and you come down here and you try to pay taxman, and you say, okay, I'm paying the taxman with itself, so it's still, I guess we'll rewrite it in the form that it was given to us, x times x plus 2. This x plus 2 is technically u, and you can see that we are in multivariable calculus now. So there are 3 incorrect things that will happen here. 2 if you do taxman perfectly. Just be aware of this. So let's go ahead and do it correctly now. When taxman fails, you always, always, always just multiply through. If it's the power of 2, go ahead and just FOIL it out. For this one, I'm going to distribute this square root of x into the x into this 2, and then take the antiderivative. So correctly, this is done by doing x to the 1/2 times x is going to be x to the 3/2 plus 2x to the 1/2. And all of that is still times dx, of course. Dx needs to be multiplied by everything inside here. That's the only reason I have to do the parentheses. All right, finally, we take the antiderivative, and because this is the power of 1, I am really just distributing this antiderivative into both of these terms. So, doing that, when I take the antiderivative of x to the power of 3/2, this is going to go up a power. It's going to become x to the power of 5/2, and then I divide down. So, divided by 5/2 is the same thing as multiplying by 2/5. And I have the same sign in between, and this was a 2x to the power of 1/2. It's going to go up a power to 3/2. Divide down, that's going to be times 2/3. Don't forget our plus c. And simplifying this just a little bit because I have to simplify that fraction. Final answer is going to be 2x to the 5/2 over 5 plus 4x to the power of 3/2 over 3 plus c. Final answer. All right, number 6. So this is going to be the definite integral of this. Oh no, we have a fraction. Get rid of it. So getting rid of the fraction, this becomes the integral from 1 to 2 of x minus 4 times x. I don't even really need parentheses here. I can just say x to the negative 2. It just becomes negative when it comes to the numerator. And don't forget our dx. So now when we look at what our u should be, you'll notice that nothing really works. I mean, you can say that x minus 4 is your u, but then your derivative of u is going to be 1. You're not able to get rid of this x to the negative 2 term. If you somehow set this as your u, you won't be able to get rid of this term. Taxman will fail. Hopefully you don't have to run through all of that, and you can maybe see it, or at least a glimmer of what that looks like. But taxman failing is kind of the same thing as number 5. You need to go ahead and distribute this x to the negative 2 into each of these terms. So I'll do that in my little notation. So this we're going to distribute into each of these terms. So this is now going to be the integral from 1 to 2 of x to the negative 1 minus x to the, or not x, minus 4x to the negative 2, all of that dx. Perfect. Now we can take the antiderivative of each of these terms individually, because this is to the power of 1, that's just a subtraction. So let's do that. I'm going to do the integral, well, I'm taking the antiderivative now, so antiderivative of x to the negative 1 is x to the power of 0. You're adding 1 divided by 0. Oh no, we divide by 0, therefore this is the natural logarithm. So this is going to be the natural log of x minus, and then this is going to be going up a power to the negative 1, and then divide down, so this can actually be a plus 4x to the power of negative 1. and all of that is evaluated between 1 and 2. And that is a hard step to get between here and here. That's a lot of tricky business with calculus. So again, just reviewing, making sure you know, bring it up, make it not a fraction, see if taxman fails. Taxman will fail because there's no way to get rid of either one of these terms by setting it equal to u. And from there, knowing that you're supposed to distribute when taxman fails. And then after distributing, it's still kind of hard because natural logarithm we haven't seen too much of. But hopefully you've gotten to here and you're able to do the substitution now. So natural log of 2, I'm going to write this all out. So this is going to turn into natural log of 2 plus, when I do 2 to the power of negative 1, that's just 1/2. And then 1/2 times 4 is 2. So that was the first substitution. And then I'm going to subtract the second substitution. So natural log of 1 is actually 0. You should know this, but I'll write this down. Natural log of 1, and you should write a note here that the natural log of 1 is equal to 0, something that you just need to commit to memory. And then we also have, when I plug in 1, it's going to be 1 to the power of negative 1, which is just 1. 1 times 4 is 4, so plus 4. All right, and this is essentially saying natural log of 2 plus 2 minus 4, so it's going to be the final answer of natural log of 2 minus 2. Oh, yeah, I was like, oh, did we forget our plus c? No, that's right, it's a definite integral. All right, last two problems, here we go, number 7 and 8. So for number 7, you can see that we are going to be using some taxman because this is going to be powerhouse. Powerhouse has the inner of x squared plus 2, which means the dinner is 2x, which is not 1. So taxman, here we go, u is equal to x squared plus 2, taxman. He's knocking at the front door again, so he's at x, or he is x. And I need to find the derivative of u. Derivative of this thing is 2x. Therefore, this fraction becomes 1/2. Let's pay the taxman with between 0 and 1. We're going to say taxman is now paid off. We have x squared plus 2 to the power of 2 dx. And now I'm going to take the antiderivative, so I still have my 1/2. So this is going to go up to the power of 3. So all of this is x squared plus 2 is now going to be to the power of 3, divide down, so it's times 1/3 out here, and that needs to be evaluated between 0 and 1. Alright, so this is going to be 1/6, that's easy to do. I don't need to actually write that down to simplify. Let's just plug these in. So when I plug them in, plug in 1. 1 squared is 1, plus 2 is 3. 3 to the power of 3 is 27. 27 divided by 6 is just, I'll leave that as 27/6. Alright, I'm going to subtract when I sub in 0. So 0 squared is 0, plus 2 is 2, the power of 3 is 8. 8 divided by 6, I'm going to leave that as 8 divided by 6, so we have a common denominator. And 27 minus 8 is 19, so your final answer is 19/6. Alright. And now to number 8. We haven't really seen a problem like this, but you might see it on the test. So hint, hint, here we go. If this thing is equal to 18, then find k. So let's just go through this problem and pretend that we are subbing in k, and then we'll solve for k once we have a cool equation from this. So if I take a look at this, I'll notice that this is to the power of 1. There's a simple subtraction, which means I'm really taking this antiderivative, this integral, and I'm applying it to both of these terms. So this integral is being applied to this term and to this term. All right, so when I do that, I have the integral from 0. Actually, I don't even want to rewrite that because I think we're fast enough. Oops, my box went away. So let's go ahead and do that. So 2kx. K, think of as a number. So this is really like 6x if k was 3. So k is just a constant. So when I take the antiderivative of this, it's going to be 2kx now is going to go to the power of 2. All of this is going to be divided by 2 because I divide down. And I'm going to subtract x cubed, divide down, and that's evaluated between 0 and k. So now we need to actually substitute our k and 0 in. So when I substitute k in, it's going to be k squared times k is k cubed. 2's cancel out, so I'm left with just a k cubed. Minus, when I sub in k again, I'll get k, oh, that's not k, k cubed over 3. That was our first substitution when we sub in k. And this is going to subtract our second substitution. And when we plug in 0, there's a 0 here. Numerator 0, numerator 0. This is just all 0. Perfect. And I can simplify this a little bit more. Let's do that now. So I can multiply the top and bottom here by 3. So if I go 3 over 3, then this is going to be 3k cubed minus k cubed, which is 2k cubed over 3. And that's as far as I can go on the left-hand side. Let's go back to the right-hand side. This was left-hand side, so right-hand side was 18. Right-hand side still has not changed. And we have like an equation that we could solve from maybe algebra 2 or something. So solving for this, multiply both sides by 3 to get rid of this 3. 3 times 18 is 54. 54 is equal to 2k cubed. And divided by 2, that's 27. Perfect. So it came out nice. K cubed is equal to 27. Cube root of 27, or 27 to the power of 1/3, is equal to 3. There's our final answer. All right, so that concludes our Fix Up Unit 5 solutions. So girls, make sure that you're studying really hard for that test. I will see you girls later. Bye.